Good morning and a very warm welcome to Breakfast with Arab. It's great to see you all. My name is Farah and I'm the Marketing and Communications Leader for Buildings London. And so to our speaker this morning. Born in Manly, which is a northern suburb in Sydney, Tim returned to the UK aged 5 to start school. Tim enjoyed an early relationship with wood by climbing trees and exploring and making tree houses. Age 3, he was found one day up a neighbour's tree, having disappeared from a family barbecue. At school, he enjoyed making, especially with wood, and in design technology, he designed and made a snooker table, a car, and a crane. He attended Durham University to study a degree in engineering, which allowed him 2 years to decide which discipline to follow. Tim graduated as a structural engineer and then came to join Arup in 1993. Starting in advanced technology, Tim experimented with crash testing and then moved to Building Engineering London after a year. Tim has a stunning portfolio of projects, including the Millennium Footbridge as the concrete designer, Wembley Park Station, the Royal Geographical Society, Sky Studios, Believe in Better, which happens to be one of Tim's most favourite Arab buildings, and more recently his beloved Pinewood Studios. And so, without further ado, I'm really happy to introduce the quintessentially charming Tim Snelson. Thank you, everyone.
Thank you. Good morning. Many are asking, is this the beginning of the timber age? The oldest buildings in the world, though, are made of wood and have outlasted many concrete and steel ones. Vertical timber slab construction has been around since Paleolithic times. Taking a look abroad, I will also explore the global support for timber with investments by governments in many countries and regions. Yet why do people seem to be so emotional about timber? Far more so than concrete or steel. Should you? The case for wood. Could you? The challenges of wood buildings. And would you? Design beautiful buildings in wood. And in this context, I will ask the question, are timber buildings really sexier than concrete or steel? So timber construction does seem to be enjoying a global renaissance. And yet timber is one of our most traditional building materials. Forests are globally recognised as having a key role in the battle against climate change, with many governments instigating forest protection and expansion programmes. A study by Broadmeadow and Matthews suggests that the carbon budget could be balanced by a 20% increase in forest area. But this equates to about 800 million hectares worldwide. And many of these studies don't seem to mention the link between growing more forest and using more timber in construction to create the added benefit of reducing the embodied carbon of our building stock. Staggeringly, the global construction industry builds the equivalent of New York City every 35 days. With 2 billion metres squared of new building construction expected each year between now and 2025. The Accord de Paris sets out the global action plan to avoid catastrophic global warming by limiting temperature change to less than 2 degrees centigrade. And the UK Climate Change Act commits us to reducing greenhouse gas emissions by 80% by 2050 compared to 1990 levels through a series of 5-year caps called carbon budgets. This approach was subsequently used as the model for action across the world by being integrated into the Accord de Paris. The global construction industry is responsible for around 15% of emissions, primarily arising from the production of steel and concrete. So while efforts to date have generally focused on energy efficiency, the roadmap to 80% carbon reduction must include a significant contribution from embodied impacts as well as operational carbon. So enter timber, the only renewable construction material, grown by the power of the sun. Our forests provide a natural carbon sink and also lock up that carbon in wood products when cut down. Timber takes very little energy to harvest and manufacture, in contrast to steel and concrete. Studies suggest that the potential for reducing carbon using timber by more than 70 or 80%. Interestingly, timber is already the second most used construction material. Yet half of this is either used in temporary works and thrown away or burnt for fuel. But timber has a strength to weight ratio similar to concrete and not far off steel. And recent timber innovations such as cross-laminated timber and laminated veneer lumber make timber construction possible on a greater scale than ever. So perhaps we need to think about moving timber up the value chain. So should you? Governments around the world are investing significantly in their timber industries. Many governments are responding to the rapid growth in the CLT market by easing regulations that previously limited timber construction to 3 or 4 stories. Timber First legislation is also starting to emerge in a number of countries and regions. Japan launched its promotion of timber legislation in public buildings in 2010. The Australian and New Zealand timber industry have received government support for starting their own CLT manufacturing after the success of local projects like International House at Barangaroo. And states like Tasmania are starting to introduce promotion of timber policies. The Timber Innovation Act in America enjoys bi-party support and seeks to establish a market for mass timber more than 85 feet tall. According to the Michigan senator who announced the bill in the March of 2017, building with wood benefits both the rural communities and the environment. The pending legislation expands on the previous US government tall wood building competition, which awarded $3 million of seed funding in 2015 to support the production of 2 exemplar projects. The funding was used to do the testing and research necessary to secure local building permits and approvals for building wood structures in excess of 3 stories. British Columbia passed a Wood First policy in 2009 and changed the maximum height of timber buildings from 4 stories to 8. The policy has seen a number of flagship projects emerging, and the University of British Columbia recently completed their student residence at Brock Commons. 18 stories high, it's currently the tallest timber building in the world. Closer to home, the Scandinavians, in their pragmatic way, have just been getting on with building bigger and bigger. Their mass timber building stock is growing rapidly, with projects like the 15-story Treat apartment building, soon to be dwarfed by the Mjøsternet, which is currently on site, heading for 81 metres and completion later this year. The UK Clean Growth Strategy commits to a network of forests, planting 11 million trees as an economical means for combating climate change and greenhouse gases. Even closer to home, the new draft London plan, currently in consultation, contains 2 significant changes affecting us all in new construction. The first is that carbon offsets, instead of being to a benchmark, will be to 0 carbon. And the second is the inclusion of construction carbon as well as operational carbon. After a couple of decades of energy regulations, our buildings have become increasingly efficient, which means that the embodied impacts needed to build those buildings are becoming a more major part of the carbon footprint of what we're doing. In theory then, if we increase forest area by 20%, using sustainable, fast-growing plantation trees, and then use these trees to make our ever-expanding cities, we can save the world. But are there enough trees to support this dream of wood cities? At a recent reception, the Austrian trade minister boasted to me that they were planting 3 trees for every one that they could cut down. So he'd like to see a large expansion in the timber market in Europe to support his timber industry, of course. And across Europe, the picture of forest growth is similarly robust. European forest stocks have steadily increased over the last quarter century, with 6 billion metres cubed increase. Sadly, this is not reflected in the UK. A neglection of tree planting has led to a reduction in our forests, down to only 12% forest cover in the UK. This contrasts with the rest of Europe, which enjoys somewhere nearer 30 to 70% of land coverage with forests. Many policy documents refer to the ability of trees to form a carbon sink and moderate climate change. And there's a strong case, though, for plantation forests that are useful because, of course, a young tree takes a lot more carbon out of the atmosphere as it's growing than a mature tree does, which has stopped most of its growing. There are many paradoxes when it comes to talking about timber and working with timber. Why do people respond so much more emotively to timber than they do to concrete or steel, say? I commonly hear it said, why use timber if you can't see it? Assuming that the use of timber is driven by some aesthetic desire from the architect. Many people don't seem to think of timber as a structural material, asking basic questions like, how far can it span? Would that work? Will it be expensive? Closely followed by, what about fire? And of course, leasing agents seem to get nervous about how they're going to market something that's made of wood instead of a concrete flat slab, preferably painted vanilla. But this year's BCO winner seamlessly blends concrete, steel, and wood all into the same building, all used in appropriate places throughout the design to get best effect and best operation. Timber is more commonly associated with luxurious fit-outs. And yet the UK CLT market growth was driven largely by the design and build contractors of the Building Schools for the Future programme and by affordable housing, both sectors which are notorious for their challenging budgets. The Building Schools for the Future contractors adopted CLT at scale because they saw it as an efficient building system, a way to build schools fast with less people on site, less deliveries, and faster fit-out to follow. So could you? Could you build more with wood? The UK is viewed across Europe as a bit of a pioneer in timber and a significant market for mass timber, with pioneering projects like the Stat House at Murray Grove back in 2009. This boasted a programme saving of 23 weeks off a 72-week concrete programme, but was amazingly built by only 4 carpenters. The Believe in Better building at Skye took timber into the commercial office market at a scale not previously done and gained worldwide recognition, not just for the technical design, but also for the speed of its delivery, having been opened only a year after Arup were appointed for the design. So mass timber in the UK has gone rapidly from 0 to well north of 600 buildings since 2009. So really we should be coming to the point where we view timber as no longer a bit of a novelty. Hardly a month goes by without somebody publishing a new study on a tall timber tower somewhere. The Council for Tall Buildings recently published its global audit suggesting over 50 buildings in tall wood on the drawing board or on site since 2014. In my view, though, these super tall trophy projects are a bit of a distraction from the main target of reducing the carbon footprint of our general everyday buildings. And a lot of people debate the sustainability issues around towers at all, given the amount of resource needed to make them and operate them. And I think we can really meet our densification requirements for urban cities at a much more humane scale of around 10 to 12 stories, which interestingly is the sweet spot for mass timber. If I suggest a timber concept for a project, I'm often confronted with questions around whether the timber's strong enough, whether it'll last long enough, can it achieve the same sort of design life, can it achieve the same fire rating. And I think it's important when thinking about these issues to separate the performance requirements, which are not material specific, they're absolute, from the design solutions we use to address those performance requirements. So every building, regardless of what you make it out of, has to comply with building regs. Has to be designed for the same load, has to be designed for the same life, has to achieve the same fire rating. All commercial buildings will be designed to the BCO guide generally, whether you make it out of wood or not. But the difference with wood, steel or concrete is how you achieve those standards. And they're different for each material. They're different for steel than they are for concrete, than they are for wood. So what are the sort of frequently asked questions, if you like, around timber? The four main things you need to think about: because it's lightweight, how does that impact on its dynamic and acoustic performance? How does wood behave in a fire? And how does it respond to moisture? And of course, this can be different quite significantly from species to species of wood. So why would we, the construction industry, want to build more in timber? Is it just about carbon? Is it about aesthetics? Or is there a sound business case for building in wood? If you could build your building lighter, faster, using less traffic impacts, making less noise disturbance to your neighbours, and with less people on site, and far less waste, would you? I suggest the business case for timber certainly merits a grown-up and detailed conversation. One of the major headlines of the Believe in Better building was its one-year completion programme, with a 3-month lead-in in design to a 9-month build programme. And a lot of that was to do with the speed of the dry timber kit that we used to build it with, eliminating wet trades and getting a very rapid weather-tight envelope. The construction time-lapse illustrates a lot of the construction benefits of timber. You can see the site is tightly bounded on all sides by other buildings and other sites. It's a typically busy construction site during the substructure and concrete phase of the ground slab. But when we get to the timber, notice how few people there are, far fewer deliveries, and how little laydown space is actually used to make what is a fairly major structure. The glulam pieces are all 16 metres long, which is optimised around a lorry length, and you'll see the facade panels come dashing round the building in a couple of minutes in their 5-week erection programme. These were installed in mostly double-storey, triple-storey or full-height panels, which again enabled very early weather tightness so that the fit-out trades could carry on in parallel with the external rain screen cladding that took the cladding off the critical path. Soon after the Believe in Better building, Pinewood Studios got their planning permission after a lengthy public inquiry. So needless to say, the client was itching to get going and gave us a similar challenge about how fast can I build it. So working with the cassette suppliers from Sky and our specialists, we developed a panel that would do all the acoustic performance and the facade performance in a single through-wall element, thereby getting rid of the traditional cavity wall construction. Astonishingly, this collaborative design solution enabled the envelope contractor to cut the programme from 16 weeks to 6 for a typical studio, and also saved around £500,000 off the budget. So despite its seemingly slow adoption, prefabrication continues to promise transformation in the construction industry. Being lightweight and easily machinable, timber fits very well into this context of prefabrication. The rapid assembly of timber on site can also translate into cost benefits by reduced prelims and earlier payback on investments. The timber industry has been innovating rapidly in terms of solution-based products rather than simply element-based products to make best use of these benefits. But we're also seeing the emergence of hybrid structures using concrete and steel in partnership with timber. The life cycle tower system developed by Arup's Berlin office uses glulam ribs on precast slabs, teamed with glulam columns and a precast core. And a number of mid-rise buildings have already been built through Austria. The benefit of this is that the concrete slab is reduced from sort of 300 to 350 mil down to 80, still achieving a 2-hour fire rating. We're also using a hybrid approach for our 22-storey building in Amsterdam. The Hout building uses a concrete core to enhance the timber frame. Many of the tall timber projects are struggling with sway stiffness and occupant comfort once they get above about 15 floors. So the concrete core adds great value in terms of stiffness, but also a robust and a safe place for escape. As the industry seeks to shift from a linear to a more circular economy, the benefits of timber are significant to help support this transition. So is timber sexy again? Well, timber can be glued, screwed, cut into amazing shapes, which can help the design team to create wonderful things and also optimize the use of timber. If we're asking what's an ideal timber architecture, well, let's work with the material's properties. It's good in axial load, which means shaping the timber into arch forms or maybe using it with pre-stress. The Sky buildings generated major program savings by the use of timber, and yet they were also designed around a progressive health and well-being agenda for the staff who occupy the buildings. There's an abundant use of natural materials and lots of daylight through the extensive roof lights. Some people comment on how fresh the atmosphere is in the Believe in Better building, and this is due in no small part to the amount of wood on show. So there are many advantages to building in wood, from prefabrication and site efficiency to carbon reduction and healthy buildings. Forests are seen by many governments as good value in the battle against climate change. By increasing growth, we can increase absorption from the atmosphere. Whilst the zealots' vision of wood cities reaching for the sky may be beyond the reach of our global forests, many designers are converging on mid-rise and hybrid solutions to get maximum bang for our timber buck and to help timber reach further into the market. This approach appeals to my engineering pragmatism. Let's use materials for what they're good at and for an optimum design. But I'm inviting us to think about our optimum designing in the context of the battle against carbon and temperature. European forests are growing at a healthy rate and can sustain a significant increase in timber construction. Harvesting trees at a sustainable rate will actually increase the ability of those forests to take carbon and help battle global warming. As we densify our cities, there are many opportunities for lightweight timber, extensions, infills, refurbishment, difficult sites. And if we seek to live and work in healthy buildings and reduce our stress, we should increase the amount of timber around us. In a world targeting 80% carbon reduction, as we seek to shift from a linear to a circular economy, we must treat every resource as precious. We must avoid over-specification and waste in construction, while also enabling disassembly and reuse. Seemed clear to me, in the context of timber should be a commonplace and significant material of choice for the industry, alongside steel and concrete. And to get maximum benefit, we're probably thinking about hybrid construction solutions, as well as all wood where it's appropriate. And timber construction, of course, is lean, it's green, and it looks great too. Thank you. So, any questions? Yes.
Do you think that the future for construction of timber is purely in forestry, or can trees that are felled in parks and gardens and just grown for the environmental benefits you can get from them, as opposed to the forestry benefits, be used more effectively in construction than they are at the moment?
That's a good question. I think planting more trees obviously helps with climate change and also local environment, dealing with pollution, all that kind of thing. So greening of our cities should be on the agenda of every development. How we use those is an interesting question. I mean, a lot of trees, once they're in, are kept in. So you're then more into the sort of trimming and offcuts and all that sort of thing. And what I found interesting was the agenda around using timber to burn it for fuel. And interestingly, obviously, that's where a lot of offcuts and things could go. They could go into biofuel and meet that agenda. So main timber, it's a case of using the value chain, isn't it? When you've got a big bit of timber, let's build something with it. When we've got a small bit of timber, let's warm ourselves with it, or make products or smaller things out of it. Does that make sense?
Hi, I'm with the Forestry Commission in London, so thank you, you're selling our job really well. Thanks so much. Just kind of answering or responding to that a bit. Yeah, I mean, I think in major construction it's plantation forestry. We have to recognise that, that's where it would come from. But I'd love to see more city timber used for sort of fit outs and to give developments a sense of place and those sort of things. So I think we could really utilise that more. There are real opportunities to do that. We're not utilising the timber we've got in cities as well as in rural areas.
There's also a question around species. Certain species are better suited to building construction. Certain species are better suited to parks and landscaping and being close to people. So that's again why we're generally talking about plantation forests. We're talking about timber industry.
Any data on the energy consumption of timber buildings versus conventional? Are there any wins in terms of the operational use of the building once it's actually being used, and whether the energy footprint is actually better?
There are two schools of thought in how you design operational buildings: lightweight rapid response versus heavyweight thermal mass. And both of those require you to manage the building actively. And that's where many buildings operate much worse than they're designed to, because actually the people who are using the building don't necessarily understand how their building has been optimized by the designers. So believe in better building achieves an operational energy performance that's basically at passive house standard. The thing is, Part L has driven us towards super airtightness, super insulation, and all of these kind of things. So if you're going to make use of thermal mass, you've got to be able to purge it, you've got to be able to manage it, and then you get the issues of lag. If it's too cold when you want to warm it up, you've then got to start pumping energy in the morning. So As I say, there's kind of two schools of thought generally, I find, amongst my MEP colleagues. Some say lightweight, rapid response. Some say heavyweight and control it through thermal mass. And both can be equally efficient, I think.
Is there any research on fast-growing conifers versus sort of indigenous, more slow-growing deciduous trees and the impact on biodiversity, what it does to ground cover, insects and food chain altogether?
Yes. Well, yeah. So the government has actually published a white paper on the role of forestry industry in their low carbon future strategy, and it talks all about those things, about plantations and about local species, which species will be better suited to our climate in 20 years' time when we're coming around to harvest them. So it's not all about growing wood to make buildings. It's not all about growing wood to make forests. And we need a coherent strategy that covers both of those angles.
Okay. As you know, it's been quite difficult for Lend-Lease to get their head around doing a timber building. But we're sort of almost there. Do you think we need, from legislation, more encouragement to do timber, or do you think the legislation in existence, like Part L or whatever it may be, is sufficient to encourage people to use it? Because it does seem, you know, taking a bird's eye view, that's the only way it's really going to be adopted. Because clients are always going to be nervous. Oh, we've done concrete or we've done steel for 30, 40, 50 years. That's what we know and that's what we want to use. And the insurers will let the insurers do it. So do you think government needs to sort of tighten everything up to force us down the timber route?
Well, that's the interesting thing about the draft London plan, actually. That's the first sign of it. You will offset your construction carbon as well as your operational carbon. So that legislation, it's coming, and it's just arriving on your doorstep. So, but of course, in classic legislative style, there's no procedure behind it that tells you how to do it. Just tells you you've got to do it. But you know, I mean, so Lend-Lease are building CLT Resi at Elephant and Castle, Deptford, and you know, this is kind of where I was trying to say we need these kind of mixed and balanced portfolios. You know, let's have lots of wood where we know we can build wood. Let's not wait for tomorrow for somebody to produce the magic timber skyscraper. You know, we can build a large chunk of our building stock in wood already. Yeah, and we can build the rest in steel and concrete.
Bridget, Mount Anvil developer and main contractor. Tim, in your experience, is the construction industry, are they up to speed with actually using timber as a material? Do they have the knowledge?
So all the buildings that you've seen here are built by specialist timber contractors. And I don't think you'd set anyone to build a concrete building that wasn't a specialist concrete contractor. Although a lot of groundwork contractors will try to convince you that they can do concrete. So at the moment, you know, big projects are done by big timber contractors. One of the challenges is growing the market to bring the smaller guys along and helping them grow up to be major timber contractors as well. And I think there's a role in clients to develop that supply chain and help more people who are good at timber to be good at doing big timber. Yeah.
Tim, I just wanted to go back to one of your points about earlier payback on investment. You noticed that through the use of just-in-time timbers and a lean construction methodology, you can speed up and reduce your costs in the program. However, has there been any studies about the cost per square foot for cross-laminated timber against the uses of steel and concrete? Because that is something as a developer we are most interested in, but it doesn't seem to be floated in the market that much.
We find we have to do it on every single wooden project we do, because that's the first question the developer's going to ask. And that's the sophistication of the conversation that I was alluding to when we talk about timber buildings. Because on the one hand, you could say, You could do a design in timber, and this is what we do. We do parallel designs. We do a design in timber, a design in concrete, and then the developer will challenge us to say something like, well, if you get it to within 5 to 7%, then we can offset that through time, through reduced prelims or whatever. But in order to do that, you have to be able to incorporate the foundation savings. You know, how many contractors are willing to sign up to the fact that they'll only need half as many people on site supervising until they've done a few buildings, which is why it was the design and build fraternity with their repeat pipeline that were able to actually start realising the savings. But yeah, we do that study on pretty much every project, and it can be a building for building comparison. Sometimes the weight saving swings it to a timber advantage, sometimes the programme saving does, and sometimes they end up pretty balanced, and sometimes the concrete is cheaper.
Is the study itself public knowledge? Can we look at it? Or?
There are a few papers that have been issued. I think people like Alinea and G&T tend to issue reports on comparing the two. And we published a paper for the World Congress on Timber Engineering a couple of years ago. So yeah, they're around there. If you want to talk to me afterwards, I can probably send you some.
Well, I think at the moment we don't use it enough, but it is quite difficult to convince people upstream, as in clients, and we are our clients in some ways, or in many ways, that timber is a good product to use. So the challenge is really at quite a fundamental level, convincing people that not only for carbon, but for all the other various reasons, and as Tim pointed out in his talk, it is actually a structural material with its own properties that is comparable to other materials. So yeah, the challenge is really just convincing people at a high level to use timber, because those of us involved in construction like I am would love to use something different and take on a new challenge.
We'd certainly like to see timber in construction being used more and more. It is low carbon, and not only that, but it helps the actual forestry sector as well. So with the Forestry Commission, we're keen to encourage the management of woodlands in the UK. And it not only delivers timber and homegrown timber that can be used in this country, but it helps wildlife. You can improve forests for public access and recreation. So there's a whole multitude of benefits from actually managing timber, cutting down trees, sustainably managing trees, and making sure a lot of those products are used and become embedded carbon for the future.
We've actually had some experience in CLT as using cross-laminated timber on 2 schools actually, and the housing as a scheme. But I think Tim made a very good point where it's actually about using the right materials for the right project. I think we can get obsessed with sort of pushing one agenda or another, and I think as good engineers or architects, use the right tool for the right project. On the school projects we worked, had a huge impact actually, because not only was it in terms of a live site working alongside one, so the benefits in terms of health and safety for the existing site, but actually when we went back and spoke to the students and the teachers, the kind of the benefits they had from the wellness point of view for the school kids was amazing actually, and I think that's a real reflection on the use of the material and what benefits it can bring.